Hello everybody and welcome back to Higher Maths with Mr. Hunter. We're still on the straight line. Today we're moving on to perpendicular lines. Now, those of you who have been paying attention over the last 4 years will remember perpendicular lines are two lines which meet at a right angle. I have drawn an example of that in. Now, we are about to do something in maths which most students hate, but us teachers love. We are going to do a proof. So stick in, people. I'm sure you'll like it at the end. Okay, so what we have is we have a line which is going out to point A. And point A has been given the coordinates AB. Now when we do a proof, we have to use letters, we can't use numbers. Now if I spin this line round 90 degrees and put it to point B, the coordinates are going to be something similar to this here. Okay, now first and foremost, the along section is actually, that along section there is actually the same as that section there. Okay, now that section there, A along, B up. That section there is B up. So this section from here to here is actually going to be minus B. The height of this point is how far along that point goes because of the symmetry, because we've switched it around 90 degrees. Okay, now the along section now, the A, is actually going to be how far up this line goes. Because it's going up in a positive direction, it will also be A. So point A is AB. Once we spin it round 90 degrees, point B is going to be the coordinate point minus BA. Now what I'm going to do is I'm going to multiply the two gradients of these lines together. Before we do that, I need to just show you quickly how we're going to work out the gradients of both lines. So if I wanted to do the gradient of, well, that point there's the origin, so I'm going to call it O. If I wanted to do the gradient of OA, O would be the point 0, 0. So I would want to do x1, y1, x2, y2. It's going to be B take away 0, which should just be B. It would then be A take away 0, which should just be A. Now if I do that for OB, again, it's going to be the difference of the y's over the difference of the x's. So it will be A take away 0, and it will be minus B take away 0, which is minus B. So my two gradients are that. You might be wondering where I'm going with this, but pay attention and you'll find out. I'm now going to multiply these two gradients together. So the gradient of OA, I'm going to multiply that by the gradient of OB. That will give me B over A multiplied by A over minus B. So when I'm multiplying fractions, I'm timesing the tops and the bottoms together. If I do that, I'll get BA, but we should always put that in alphabetical order. So I get AB. On the bottom, I'll get A times minus B minus AB. Now, we are dividing something by itself, but the bottom bit is actually a negative. Now if we divide something by itself in maths, the answer would always be 1, but because one of them is a negative, the answer here is actually minus 1. Which leads us on to a very important thing. If we have perpendicular lines, their gradients will multiply together to make minus 1. If OA is perpendicular to OB, then the two gradients, let's just call it M1 and M2 just now, will multiply to make minus 1. If we have perpendicular lines, their gradients will multiply to make minus 1. That is a mathematical fact. Now we're going to spin it round. We're going to spin round that bit of logic. Conversely, if m1 times m2 equals minus 1, if we have two lines that the gradients multiply together to make minus 1, then m1 and m2 are perpendicular. Okay, so if we have perpendicular lines, their gradients will multiply together to make minus 1. If we do that in reverse, if we multiply two gradients together and we get minus 1, it must mean that the lines are perpendicular to each other. So there's a little bit of mathematical facts for us that we're going to use when trying to calculate gradients of perpendicular lines. Okay? For example, if I have a gradient of minus 3, okay, and I want to find the gradient of the line which is perpendicular to that, well, I know that perpendicular lines multiply gradients to give me a minus 1. So if I have a minus 3 as one of my gradients, I'll end up with this. How will I get this gradient by itself? That's what you're going to have to work out. Get it by itself, get rid of the minus 3, it's multiplying on this side, take it to the other side, it would be dividing. So the gradient of my other line is going to be minus 1 over minus 3, that's going to be a third. So if we have a line which has a gradient of minus 3, the perpendicular gradient to that will be 1/3. They go together in a little partnership. Okay, now what if I had points? What if I told you that I had P, which is the point 2 minus 3, and we have Q, which is the point minus 1, 6, and I want you to find the gradient of a line perpendicular to PQ. Okay, so I want us to find a gradient of a line which is perpendicular to PQ. You're given the 2 points. The first thing you'll need to do is work out the gradient of the line PQ. So gradient of PQ, that's going to be 6 take away minus 3 over minus 1 take away 2. 6 take away minus 3 is 6 add 3, which is 9. Minus 1 take away another 2 is minus 3. 9 over minus 3, well 9 over 3 would give me 3, but it's a negative. So we get a gradient of minus 3. I want the gradient of a line perpendicular to this. Okay, well if I know that the gradient's minus 3, I know my little relationship about perpendicular lines, their gradients multiply to make minus 1. So I'm going to put minus 3 in there, and it actually works out to be the same as what we just did a minute ago. So I'm trying to get m2 by itself, so I get rid of that to the other side, and I get a gradient of 1/3. So the question was, you're given P and Q, you have to find the gradient of a line perpendicular to PQ. So the first thing you need to do is get the gradient of that line, and then we're going to do a perpendicular gradient. Now what I want to show you is they might actually get a little shortcut method for doing the gradient. Okay, we might get a shortcut method. If I told you that I have a gradient of 2/3 and I want you to get the perpendicular gradient. So what we would do is we would say, well, m1 times m2 equals minus 1. I'm going to pop my 2/3 in here. I'm going to try and get m2 by itself. So that means I'm going to take the 2/3 to the other side. So the 2/3 is going to divide on the other side. That's a horrible looking thing. Minus 1 divided by 2/3. You need to remember how you divide with fractions. That was done in National 5. Okay, let's have a little look at this. If I wanted to do minus 1 divided by 2/3, it would look like that. Now, I would like both these things to be a fraction. So if I want to make minus 1 a fraction, I can just put it over 1. Now, dividing fractions, the rule is change the symbol to times and turn the last fraction upside down. You should remember that from last year. Now I'm left with a multiply fraction, so I'll times the tops together. Minus 1 times 3 is minus 3. Or times the bottoms together, 1 times 2 is 2. So if I have a gradient of 2/3, the perpendicular gradient to that is minus 3 over 2. Can you spot a relationship? Can you spot a fast way of doing it? The other example we had was if we had a gradient of minus 3, then the perpendicular gradient was 1/3. Can you spot a fast way of doing it? If we have a gradient of minus 4 over 7, the perpendicular gradient will be, anybody? Follow what is happening. We are turning the numbers upside down and we are changing the symbol. Minus 4/7 will become positive 7 over 4. That is the fast way of getting the perpendicular gradient. If I had a gradient of 2/9, the perpendicular gradient to that would be negative 9 over 2. The only thing you need to just watch out for, say we have a gradient of 5, the perpendicular gradient, so if I'm talking about turning the fraction upside down, 5 doesn't look like it is a fraction, but remember 5 is really 5 over 1, so if I turn it upside down it would make a 5th, and I change the symbol. So the fast way of working out a perpendicular gradient is you turn the fraction upside down and you change the symbol. A negative becomes a positive becomes a negative. That is the fast way of doing it. Okay, now we have an exception to the rule, and the exception to the rule is our horizontal and vertical lines. So remember, a vertical line has an undefined gradient. We've spoken about this before. A horizontal line has a gradient of 0. Now we can clearly see that these lines are perpendicular to each other, but because this one is undefined, we cannot use the formula, because we can't multiply by something that's undefined. It's impossible. So if you come across a line which has a gradient of 0, you're just meant to know that the perpendicular line is going to be undefined. If you come across a line which is undefined, you are meant to know that the perpendicular line is going to have a gradient of 0. That is just a fact. You're meant to know. You're not meant to try and use the formula. The other thing that we can do with this is we can try and prove if something is right angled or not, particularly triangles. So what I'm going to do is I'm just going to draw a little triangle out. So we're going to say that R is the point 1, 2. We're going to go with S is the point 3, 7. and we're going to go with t as the point 60. And I'm going to join this up to make my triangle. Okay, now we are going to try and prove that this is right angled. That's what we're going to try and do. Okay, now by looking at this, you might already have a good guess at which angle might actually be the one that's right angled. But as I haven't drawn this to scale, it might be wrong. But you might be looking at this thinking, that one looks right angled. So we're going to check to see if this is right angled. If it's right angled, then that line and that line are going to be perpendicular to each other. So what we need to do is we need to work out the gradients of those two lines. So I'm going to work out the gradient of RT. So 0 take away 2, 6 take away 1. So that's going to give me minus 2 over 5. I am then going to work out the gradient of that line there. So that's RS. So that's going to be 7 take away 2, 3 take away 1, which is 5 over 2. Okay. So the gradient of RT is minus 2 over 5. The gradient of RS is 5 over 2. Does that mean we have a right angled triangle? Well, let's check. If we multiply the two gradients together and get minus 1, then we have perpendicular lines. And if we have perpendicular lines, then the triangle is going to be right angled. Let's try that with the two gradients. Minus 2/5 times 5 over 2. What is that going to give me? That will give me minus 10 on the top. That will give me 10 on the bottom, which will cancel down to make minus 1. So in this triangle, we do have a right angle. And I would just comment at the bottom that triangle RST is right angled at R, because that is where my right angle was. Okay, so we can use this fact to work out gradients, but we can also use it to prove if a triangle is right angled or not. Remember, the fast way of getting the perpendicular gradient is to turn the fraction upside down and change the symbol. Right, time for you to do some work. So, first batch of questions. I want you to write down the gradient of a line perpendicular to the line with gradient. We've got minus 2 over 3, a quarter, minus 5, 0, 1/7, and 4/3. Then I'm going to give you A is the point minus 1, 2, B is 8, 1. Find the gradient of a line perpendicular to AB. And finally, I've drawn a triangle for you. A is minus 5, 0, B is minus 2, 3, C is 3 minus 2. You have to prove that it's right angled. So hit pause on the video and do your work, folks. Okay, so the first one, minus 2 over 3. If I want to get a perpendicular line to that, imperp, turn it upside down, change the symbol. 3 over 2. So if I'm going to get a perpendicular gradient, I'm going to call it imperp, because that's what all the cool people do. 1 over 4, 1/4, upside down, change your symbol, minus 4. I would get minus 4 over 1, but in a fraction you don't need to write over 1. Number 3, minus 5. Imperp. Turn it upside down. Remember, it really is minus 5 over 1. Turn it upside down, change the symbol, I get 1/5. 0. spoken about that already. That is a horizontal line. The perpendicular line to that is undefined. Question 5. 1/7. Perpendicular, turn it upside down, change the symbol. -7/1. We don't need to write the over 1. Final one, 4/3, 4/3. Perpendicular, turn it upside down, change the symbol. -3/4. Question 7. We're given 2 points. We're given A and B, and we've got to find the gradient of a line perpendicular to them. Okay, so -1, -2, and 8, 1. I'm going to get the gradient of AB. So it's going to be 1 take away -2. It's going to be 8 take away -1. And then we're going to work that out. 1 take away -2 is going to give me 3. 8 take away -1 is going to give me 9. 3 9 simplifies to make 1/3. I'm then going to write down that I have perpendicular gradients, and then I'm going to work out what M-perp is. Turn it upside down, change the symbol. Okay, it is 1/3. Turn it upside down, I would get -3/1, but I just need to write -3. Now, little point here, if we're doing this in exams, we need the statement. Without the statement in a test, in an exam, you won't get full credit. It tells the person you know the relationship for perpendicular lines. Okay, last one. Number 8. Prove that this triangle is right angled. Now, by looking at this triangle, I'm thinking that the right angle would be there. What do you think? Is that right? Of course it's not. Or is it? Or is it going to be there? We're not sure at this point. We need to double check it. Whichever one you think it is, you go for that one first. Okay? I'm going to go with this bit here. So that means I want the gradient of AC, and it means I want the gradient of AB. So first things first, the gradient of AC, that's going to give me -2 take away 0, 3 take away -5, which is going to give me -2/8, which will give me -1/4. Now I'm going to work out the gradient of AB. That's going to give me 3 take away 0. That's going to give me -2 take away -5, which is going to give me 3 over -2 add 5 is going to give me 3, so that's 3/3, so that's 1. So I can tell that this is not right angled at A, but some of you might be thinking that it's right angled at B. Okay, so I've got the gradient of AB, I just need the gradient of BC now. That's going to be -2 take away 3 over 3 take away -2. So that's going to give me -5/5, which is going to give me -1. Okay. If I multiply those two gradients together, it gives me -1 as my answer. So this triangle is right angled. AB and BC are perpendicular, so the right angle is up there. To communicate that answer, which is very important, you would write something along the lines of this, as the gradient of AB times the gradient of BC equals -1. The triangle is right angled at B. And that, everybody, is perpendicular gradients. We're adding it in. It's another way of finding the gradient of a line. And that is your first proof at Higher Maths. Enjoy!